After the Big Bang, the universe had gone through its first dramatic stages. Nucleosynthesis created the lightest elements, recombination allowed atoms to form, and photons were finally able to travel freely through space. That moment left behind the faint glow we now call the cosmic microwave background. Yet after this milestone, the cosmos entered a long and quiet phase. No stars burned, no galaxies shone. Instead, there was only darkness, filled with scattered hydrogen and helium atoms. This vast and silent era is known as the Cosmic Dark Ages. The universe at this point was not empty, but it lacked the brilliance we associate with the night sky. Neutral hydrogen and helium drifted in great clouds, spread thinly across the expanding cosmos. There were no sources of light to illuminate the scene, no structures yet large enough to stand out. To imagine this era is to picture a vast ocean without waves, calm on the surface but slowly changing beneath. The seeds of that change had already been planted. Tiny variations in density, imprinted during cosmic inflation, ensured that matter was not distributed perfectly evenly. Gravity began to work on these irregularities, drawing atoms together into small clumps. At first the effect was subtle, but over time these regions grew denser, pulling in more material. The universe was dark, but it was not static. Invisible structures were slowly taking shape. During this period, light still interacted with matter in limited ways. Neutral hydrogen could absorb and emit radiation at specific wavelengths, most notably the 21-centimeter line. For modern astronomers, this signal is a key to studying the Dark Ages. But for the universe itself, it was only a faint and quiet background process. Overall, space remained opaque to any visible change. For millions of years, conditions stayed this way. The gas cooled as the universe expanded, and the small fluctuations of matter grew into larger clouds under the pull of gravity. These clouds became the precursors to galaxies. Yet to an observer within the universe, the scene was unchanged. No points of light, no stars to break the uniform darkness. The silence of the Dark Ages lasted for nearly 200 million years. Slowly, within the densest clouds, hydrogen gathered in sufficient quantities for the first time. Under gravity's relentless pull, these clouds compressed, and in their cores, temperatures and pressures began to rise. Eventually, nuclear fusion ignited. The first stars were born, massive and short-lived, but powerful enough to end the long night. Their light and radiation marked the beginning of a new cosmic era, the epoch of reionization. The Dark Ages were not wasted time. They were the transition between a glowing but featureless early universe and the structured cosmos that would follow. Without this quiet interval, matter would not have had the chance to collect, and stars and galaxies could not have formed. Though no visible light shone, the foundations for everything we know were laid in this period of preparation. When we look at the night sky today, filled with stars and galaxies, it is worth remembering that there was once a time when none of them existed. The universe had to endure centuries of silence before the first lights appeared. The cosmic Dark Ages may seem like emptiness, but in truth, they were the necessary beginning of cosmic structure. The calm before the stars,